So now in this session we are going to understand what is meant by algorithms in Java. So there are many types of algorithms in Java. So first one is the sorting algorithm, next one is searching algorithm, next we have graph algorithms. So in this session we are going to understand detail what is meant by searching, sorting and graph algorithms. So if you observe, so what is meant by sorting? So sorting is nothing but how you arrange the order. If you have from ascending order, you have descending order. So these are known as sorting orders. And if you go to the Amazon, like there you can see the list like sort by prices, sort by the date uploaded, like that, sort by deals, like that you can see. So there we can use this algorithm to have a minimal price and a maximum price at the bottom, or you can have in the descending order as well. So there is a inbuilt method in Java that is known as collections.sort. With the help of this single line, you can able to sort all this stuff, and you can also have the array.sort. So this is not the thing that we are going to discuss in this video because it's a easy thing, but we are going to have in the DSA, that is in the with the help of the manual implementation. So we are going to understand what is bubble sort, what is selection sort, what is insertion sort, what is merge sort, and what is quick sort in this video. And if you also see in this video only, we are going to cover what is the searching algorithms. So for the searching also, we have the inbuilt options provided by Java, that is collections.binary search, array.binary search. Basically this works on the arrays or arrays. So if you see clearly, we have for everything searching and sorting we have manual implementation. Why? Because in languages like C, C++ we have only manual implementation. Like majorly in C we have only manual implementation. So with that reason, in the consideration in the Java also we have inbuilt methods. With that sidewise, if you customize that inbuilt methods, you can also use this manual implementation. So you means under beneath this, that is going to work with the help of these two methods only. So one is linear search and second one is binary search. So according to your use cases, you can use linear or binary. So linear will be used when the array is unsorted, and binary used when the array is sorted. You can see sorted over here, sorted array. The next algorithms are known as the graph algorithms. So in the graph algorithms, when we need to use the graph algorithms. So we have to use these graph algorithms like when you have the trees, like graphs like that. If you have, you can use these graph algorithms. So what are these graph algorithms? You have breadth for search, BFS, depth for search, DFS. So we have Dijkstra algorithms. So this is to use to find the shortest route, shortest path between nodes of in a graph. So Kruskal prime algorithms. So used to find minimum spanning tree. So these and all things will be important algorithms when you go further ahead. So other types of algorithms also we have DP, that is dynamic programming. So if you see in the lead code or somewhere else, the important questions might be of using many important questions like NQs. That kind of questions will be based on the dynamic programming. So in this, what we will do, we are going to store the previous values so that we can use with the help of this memoization. It is not memorization, it is memoization. And we have some greedy algorithms, and we have some hashing methods also. With the help of hash map, we are going to have hashes. We are going to do hashing algorithms. So if you go further, so let's start with the searching algorithm. One is linear search and second one is binary search. So in the linear search, what is meant by that? So checks every element one by one suitable for small and or unsorted data. So assume that you have an array called nums. So you have already know that the array will be indexed with 0. That is 0 based indexing, that is in Java. So as this is a searching algorithm, you need to search a given element, whether this element is present in the particular array or not. Suppose that you have an element like 6, we have to search in this array. Is that in this whole array, is the 6 is present or not? So if you observe manually, there is 6. So if you see what is meant by linear search is each and every index we need to go manually. So at the first index we need to check if that is not equal to 6, we need to go forward. If that is not equal to 6, we need to go forward. If that is not equal to 6, go forward. So at the index 3, we are going to have the 6, means if 6 is there, we are going to return that is true. If like that, if this is not 6, we are going to forward, then out of the array, so we are going to say false, the array is not present, the particular given target is not present in this nums array. So this is known as the linear search. So we will also see the code implementation so that you will be very familiar with the code as well. 9, 1, 6, 4, 2. So these are the elements that I have in the array. So after that, what I will be going to say is I will be going to have target. So I will say set the target as 6. That is your wish. You can set whatever the number you want. So first of all, we will check is this 6 present in this here. If 6 is there, we are going to return the index. So see, the index is 0, 1, 2, 3. So that will be basically going to return us the index number. So after that, what I will be going to do is I will say this int result. Basically this result, inside this result we are going to call linear search. So I know this linear search is a function that is accepting the nums array, and it will also going to accept the target. So I know this linear search function is not made by me now, so I will make after I have the result. Means this linear search function will return us the index if the element is there, and or if the element is not there, it will be going to return us -1, and we are going to store in the result thing, because that seems simple. So if result is not there, if result is -1, because if this -1 is there, if this linear search returns -1, if there is no element in that, what we are going to say is we are simply going to print something in the terminal. What we are going to say is element not found. And the next thing that we are going to say is the else statement. In the else also we are going to say that if array is equals to -1, then we can have the opposite statement. But what I am saying is if array is not equal to -1, basically if array element not found, I am saying if element found, we can simply say element found, and we can have the result here. Basically it will show the index number. Or if element not found, if a result is equals to -1, then we are going to say element not found. So this is a simple syntax. I hope you understood this. This is not that much tough. So after what I will say is, after this main function, I will come down and I will be, if you hover that, it will show quick fix. Create a method called linear search, and in that we are going to accept int array on the integer in the demo. So if you click that, for you it will be going to create a private method, static integer called linear search, accepting an array and accepting an integer, and inside that it is storing an exception. So for now I will be going to remove this one. So like that you can use the thanks to VS Code, with the help of VS Code you can simply quick fix that, and you can it will be going to directly give you these methods. So inside this method what I will be going to do is, so basically I want this fix. So as this is the linear search, I will be going to have simple for loop. So inside this for loop I will be going to start with integer I is equals to 0, and up to where this I will be going is I less than nums dot length. Here you can see we are accepting here the nums, so it will be going to up to the last element, and finally we are going to increment that. So we successfully we are able to traverse this nums. So after inside this traversal, what you will be going to say is if nums of I is equals to target, because we are accepting the target here as well. So we are checking here. So this will return the index number I. So we are starting from 0. If the nums of I, the first element is equals to the target element, return the first element's index I. So that's what it is saying here. At last we need to return something also, because the whole return type is integer. So if you not found anything, just simply say return -1. So that's what we are doing. So it will be going to erase the error. So now what I will be going to say, I will just simply compile and run. So it is returning as element found in the index 3. So you can simply customize that element found in the index. That's it. If you be able to customize, you can customize. Okay, now let me recompile and run. You can see it is clearly saying element found in the index 3. You can also clearly see over there. You can see we are passing 6. We are checking for the target element 6. Is this present or not? So if you want to check for the index 2, it is in the last element. So if I again compile and run, it is saying in the index 5. So you can also say 0, 1, 2, 3, 4, 5. So it is present. Suppose what if I have an element like 10, which is not exist in this nums array. So if you compile and run, so it is saying element not found. So that's a simple thing that is the. So if I again come to this slide, and if you see this is the thing that we are going to searching in the array with the help of the linear search. Now if you compare the time complexity and the space complexity in this linear search, so let's understand the time complexity, because for that only we are going to optimize for the binary search if the data set is large, or if the data search is first itself is sorted. So if you observe the time complexity, always you are going to see with the worst case. So if you see the worst case, that is order of n. If element is not present or at the last index. If you're checking the element with the element as 4, so that is order of n. So I hope you understood the linear search. Now if you see the searching algorithms, that is the binary search, we have only 2 searching algorithms. So linear we completed, now the binary search. So basically the binary search is another implementation. How you implement, let's see that. So efficiently find an element in a sorted array by repeatedly dividing the searching interval in half. So what is meant by this is, if you have an array called nums, as you know, the array is the 0 based indexing. In the same fashion, if you also want to find the target, so how you will do that? So first of all, you need to sort the array, because you can see over here it is said that already said mention. So on the sorted array. So it is not sorted. It is the 5, 9, 6, 1, 6, 2, 4. So it should be sorted first. So for the sorting only we have many algorithms. In this session only we are going to see that. So after sorting, the array looks something like this. So 1, 2, 4, 5, 6, 9. So for the sorting, I have said before only, we have these many algorithms we will be going to see in this session. That is bubble sort, selection, insertion, merge, quick. These are all things we will be going to see. So after you successfully sorting that, what we are going to do is we are going to initialize this first element and the last element like your wish. So I am going to say the first element as L, that is left, and the last element as R, that is right. Take 2 pointers left and right. So point to the first element of left. So right points to the rightmost element, that is the 5 in this case. So now you need to calculate the mid. So how you will be going to calculate mid? Left plus right by 2. So in this case we have left is 0 and right is 5. So simply 0 plus 5 by 2, that is the 5 by 2. So as 5 by 2 is 2.5, as this is the programming language, 2.5 will be cutted, and as integer it will take 2. So here the second index, that is the mid value. Now we are going to compare this mid value. Is this equal to target? Is this target 6 is equals to 4? No, that's not the correct one. So the next step that we are going to see, we are going to compare. Is mid is equals to target? Is 4 is equals to 6? No. This 4 is not equal to 6. The next step is we are going to check the target element is less than nums of mid. So what is the nums of mid? So this is nums, this is mid. So nums of mid is 4, the target is 6. So as this is sorted, the 6 will be greater than this 4. So you are going to discard whole this one. Below the 4 you are going to discard. You are going to only consider this one. For more understanding purpose, I am taking the target as 2 and the target as 6 as well. If you take target as 2, so again you need to move your left, or if the target is less than that, you are going to assign the right to mid minus 1. So if the target is 2, as we see now, the target is 2, you are going to take this right pointer, you are going to place on the 1, on the index 1. So that's the simple stuff, okay, in this fashion. In this fashion, you are going to place the right, you are going to move the right pointer to here, and you are going to discard all the stuff in the right side. If the target element is 6, you are going to discard whole this part, and you are going to place this left pointer, and you are going to place the left pointer here. I hope this makes some sense. So move the right pointer here. So what is the use of this? Now only I will explain what is the use of this. Again, recalculate the mid value. So 0 plus 1 by 2, that is 0. So the mid will be placed now here. I will show that. So here also calculate the mid. 3 plus 5 by 2, that is 3 plus 5 by 2, that is 4. So place the mid value there. So as the 3 plus 5 by 2 is the mid value, the 4, that is index 4. Now target element is equals to the 6, that is the correct value. Now here if you compare, so 0 that we are getting mid value of 0. So move the mid value here 0. Now you can see the target value is 2, but the mid array nums of mid is not equals to the target value. Now what we are going to say is, so again we are going to have, we need to compare this mid value. Again we need to recalculate the mid value. Okay, that is again we are getting 0. So after that what we are going to say, with the help of this left pointer, again we are going to move mid plus 1, because the nums of mid is less than that. So you are going to move this left pointer here. So after that the left pointer, the right pointer, all points here, and the mid also will point here. So then we can say the number is present in this. So in this nums also, if you see that nums of mid is equals to target, so we can simply return true or index number. We can simply return this exist, or we can simply say return this index number. So that is only that is the thing. You need to merge this left pointer and right pointer in this case, and you can see this matches. If left is equals to right is equals to mid, the number matches. Or in this case, the middle array of nums of mid, if that is equals to target, nums of mid is equals to target, you can say the number exists. So these are the two possible cases that how you can say the number exists. So what if the number does not exist? So take the target number as 3. So before the case as the same. So up to here is the same. The mid element is 2. Up to here is same. So after that what we are going to say is, again we need to recompile the mid. So the mid is 0 here. You can see the mid is 0. Up to here is the same. Now what you are going to do is, you are going to move this left pointer here. Okay, you are going to move the left pointer here, and the mid will be same here. Why the mid will be here? Because 1 plus 1 by 2. That's only. Left plus right by 2. That is 1 plus 1 by 2. That is again the same thing. That is 1 only. So with this also we are going to assume that nums of mid is not equal to target. So with this we can say, or we can return -1. The number does not exist. So this is the code that we have seen for the linear search. Okay, so I will be going to keep this as the same. The array will be same and the target is also same, but this thing I will not more than I will be going to say this as linear search. I will say binary. So this is the binary search which accepts an number, the array, and which accepts the target. So in this, the same stuff that I again printing. So I will be going to remove this here, and if you hover over that, it will be going to ask say you quick fix. So it will be going to say create a method binary search in the demo, or you can simply right click that. You can say see source action, click on that. No, in this source action it is not showing. So you can simply hover over that. You can simply click quick fix, create a method. So basically it will be going to create a method for you. Okay. For now I will be going to remove this throw error. Okay. In this method, what I will be going to do is, so as we are accepting the array, as we are accepting the target, with this we also now we need to calculate some stuff. That is you need to calculate the left value. Okay, that is 0, and you need to calculate the right value. So you can, for the right value, you can simply say the nums dot length, because you know already that nums dot length is the last final most element. So the nums dot length will give you the last element, but it will not going to give the correct index. So for correct index you need to say -1, because array is 0 based indexing, so you are going to say -1. Okay, so in this version you are going to calculate the nums of left and nums of right. Okay, so after this what you are going to do is you are going to mention the while loop. So inside the while loop, if the left is less than equal to right, that's only right. If less than equal the left is less than equal to right only, then we are going to execute the first case. If you see here as well, here not wait. So if you see here also, when we are starting, the left is the leftmost one, the smallest integer, that is 0, and the right is the greatest one, that is 5. So from this we can say if the left is less than right only, that then only we are going to execute this. So if you come here in this while loop, what we are going to execute is we are going to calculate the mid value, that is left left. So what I will be going to say is left plus right, and I am going to wrap inside these braces, and I will be going to say by 2. Basically this will be going to calculate mid for me. So if I code the mid, so again in that nums of, I will be going to say nums of mid is equals to target. Basically you can see over here we are importing the target, means we are accepting the value target as well. So as we are accepting the nums, with the help of nums we are finding the leftmost the index and rightmost index. In this while loop, what we are calculating the mid, and after calculating the mid, you are going to check whether nums of mid is equals to target in the first step. So this nums of mid is equals to the target, whether it is equal to 6, the target is equal to the 4. No. If this is the case, then we are going to simply return here only. So we can simply say return the mid value. Mid means here the index value. You can simply return that, or you can simply else if that. So for example, after below this one I will mention that else if. So basically in this else if, what you are going to say is if the nums of mid is basically why I am doing this is else if means you are going to check whether the nums of mid is less than the target. If that's the case, move the right pointer towards the mid -1, do the mid -1. So you are going to have this stuff. So you are going to say else. Finally what you are going to say, you are going to return. So this is the simple stuff that what I am doing here. You are not going to do this stuff, but so I hope you may this all makes some sense now. So if the nums of mid is equals to target, return that mid directly. If else if do the left plus, else if do the mid -1. This and all stuff is clear for you now. So as if, finally as you are returning the integer, so you can return the final integer as well. That is if you not found anything, you can simply return -1 over here. So basically it is all the code is now right, you can see. So we have just did nothing. With the help of this binary search function, we are accepting the numbers, we are the array numbers. So we are accepting the target, and we are finally calculating the left, right, and we are calculating the mid, and we are able to check with the help of this simple if else statement. And if that's not the case, we are simply returning the -1. So that's it. We are just, if you run that, compile and run. Wait, I will zoom out a little bit. So I will clear the terminal for you, and if I compile and run, it is saying element not found. Why it is not saying that? Because you have an element 10. So if you change this element 10 to suppose 5, or if you say that 6. So I missed a small important thing that I forgot to mention, that in the upcoming session only we are going to cover the sorting part. So as why this is giving element not found, because we are not sorting the array. Understood? I only already mentioned many times that array need to be sorted for this stuff. So what I will be going to say is, suppose for example I am saying, so this stuff, okay. So I will be going to remove this and I will be going to play some. So I hope you understood. The array should be sorted. If I search for the 6, so if I again mention the 6 so that you can understand, so I will mention the 6 as well. Now what I will do, recompile and run. It is saying the element is found at the index 5. So the overall code is correct, but due to this small logical error, first of all we are rejecting element not found. But after that we have changed that to the array sorted order. We are going to see all the sorting methods in this video only. So if you check for the 9, it will be going to say, if you recompile it, it will be going to return you index. Or if you going to say the 49, and it will be going to return the index. So it is saying index 9, and if you say somewhat 50, or if you say 60, it will be going to return you the -1, or it will be saying element not found. You can see the element not found. So this is a simple thing that is known as binary search, with that we have seen with this